In this video, we are going to go over the process of imposing a design constraint on strength ratios for composite laminates in MSC Nastran Optimization. This is Christian. If you have any questions, comments, if you want training, mentorship, guidance on a project of your own, if you want access to the web app you see today, you can email me and I'll definitely work with you on getting any of that set up. So here on this section that you see me circle with the mouse cursor, we see that our current, here, let me see if I understand this correctly. Our smallest strength ratio is currently 0.21 for lamina 8. This is indication that there is insufficient strength for that lamina. What we want to do is impose a design constraint that says, for each lamina, make sure that the strength ratio is greater than 1.1. Here we have the initial layout with the mass and the ply thickness. After this video, after I show you how to create the constraints, we arrive at this new mass, this new layup, this new thickness, and we find that the strength ratios for all the laminas are greater than 1.1. So now let's go ahead and work on setting this up. This example is from a larger example I've done. I definitely suggest you watch this larger video I have on YouTube that walks you step by step through the process of this example. But in this video, I'm just going to focus on, again, the design constraint on strength ratio. So we are going to create 8 design constraints, 1 per each lamina. And we are going to say that the lower bound for this strength ratio design constraint is 1.11. And now let's go ahead and work on that. Did I use 1.11? That's the question I have right now. I've done this example before, and right now I'm wondering if I mistyped 1.11 or should be 1.10. And let me go ahead and see what my previous example did. I did use 1.11. Okay, so let's go ahead and use that then. Open your web app, and this web app is available either when I offer you mentorship or if you opt in for the more advanced training I have. So after you load the web app and you load the constraints page, search the list for strength ratio, and here you get a corresponding response type, composite strength ratio. Click on this one time to create a constraint for the strength ratio. And here, let's go ahead and type in the lower allowed limit or the lower bound. Let's type in 1.11. We are going to apply this to element 64. If you are wondering why it's element 64, I definitely recommend you view the other YouTube video I mentioned. And then if not, feel free to send me an email. I'd be more than glad to discuss why element 64. Here in this box, we'll go ahead and type in 1 for lamina 1. As for the composite strength ratio item code, that is located in the MSC Nastran Quick Reference Guide, Chapter 6, Section Element Force Item Codes. If you go to this section, now look for the C quad 4 element corresponding to the composite type. So that'd be C quad 495. And I'm using MSC Nastran version 2016 here. Here, if I look down the column, I see that for item code 5, this corresponds to the strength ratio. And you can see it also corresponds to the failure index. Here, I know that I am working with the strength ratio response type. So the 5, or rather MSC Nastran will understand I mean strength ratio, since the constraint type is CSTRAT. If I were to instead have used failure index here as an example, so composite failure criterion, if you use 5 for this constraint type, it would then use the failure index. But here, let's go ahead and go back to my strength ratio. So let's go ahead and create 7 additional constraints, one for the other 7 laminas. And let me go ahead and create the 8th constraint. And like before, let's go ahead and assign a lot of the same values to the other boxes. So this is being applied to LM64. They will all have the same bound of 1.11. Here we are seeing that whatever happens, the strength ratio cannot be under 1.11. And we are doing this for lamina 1, 2, 3, 4, 5, and all the way up to 8. And we are using the same item code for the other ones. So let's go ahead and type those in here. And now what I can do on the right hand side is copy this output and use it in my design model. And this completes the creation of our design constraints. You can see I've already created my design objective and design variable statements. Let's go ahead and perform this optimization. And here, let's go and refer to my PowerPoint and discuss what we expect to have. Here on the left is the initial design. It had a mass of 1.6. My layup had 85 and 60 degree plies. Thickness was 0.01. But more importantly, my strength ratio, the smallest strength ratio I had was 0.21 in lamina 8. So this was definitely exceeding the lower bound of the design constraint. Here on the right is what we expect. We expect a different mass, a different layup, and a different ply thickness. But more importantly, the strength ratio, the smallest strength ratio out of all the laminas is now 1.107 for lamina 3. And this was our intent. Let's go ahead and open the F06 file and confirm that that is what happened in here. I'm having the continuous issue of memory. So let's go ahead and close some of these applications and rerun the optimization. Just in case you're new to my videos, the reason this happens where the optimization doesn't go through all the way is I'm running a virtual machine. Here, let me minimize this. I'm actually running a Linux host environment. So this Linux virtual machine has a very small amount of memory. And if there isn't enough, of course, the optimization won't successfully complete. But now I close some of the open applications, so it should be able to complete this optimization now. And I'll do a quick call out. My name is Christian. If you want access to this web app, if you want guidance on the fastest method of performing your optimization, if you're starting out doing optimization, I'll also provide more advanced training. And all it takes is just a simple email to me that would take maybe 1 minute to write up and send to me. And I check this regularly, so you'll definitely have a response to me as soon as possible. And now let's go ahead and look at my results. And maybe let's go ahead and open my F06 file and see if my analysis or optimization is complete. Let me scroll through the bottom and I see that the optimization when I open this is currently at design cycle 9. Let's go ahead and refresh this output and see what optimization cycle it is at now. Before it was at design cycle 9, now it's at design cycle 14. And I expect this to go up to design cycle 19. Okay, so we are on 14, so it should be finishing shortly. I've done this example before, so that's why I have these results here. So now let's just discuss the results here while we're waiting. You can see our 85-degree plies are now 47-degree plies. Our 60-degree plies have become 2.3-degree plies. Our thickness is 0.02. And we've actually been able to reduce the mass of this composite laminate. And now let's go ahead and update our F06 file. And we'll look at the very bottom of the file and see if we've completed this analysis. And yes, we have the message that says run terminated due to hard convergence at an optimum. So we've successfully completed the optimization. Here in this column, I see what my masses were throughout the optimization process. So at the very beginning, I had a mass of 1.6 inches. So that would be this value. And then at the very end, I had a value of 0.36 inch. Here are my design variable histories. And here at the very end, I end up at a thickness of 0.002, 47 degree, and 2.23 degree plies, which is the same thing I had in the PowerPoint that I just discussed. Now let's go ahead and view the results in Patran. This is where I originally started the entire model. This is where I built the model, where I performed my first analysis. This is where I found out that maybe the strength ratios were not sufficient for my needs. And actually, let me make sure I'm attaching the right result file. As I detail in the YouTube video I mentioned at the very beginning of the video, I go from the moment you output the model from Patran, and I'll walk you step by step on how to configure an optimization example for MSC Nastran. But if you need additional guidance on how to set this up, again, I'm one email away. Definitely feel welcome to send me an email. And I'll definitely get back to you. And now let's go ahead and apply the results to Patran. And then at this point, I'll be able to view my strength ratios for element 64. And again, they should be higher than 1.11. So let's go ahead and view a French plot of this. Or rather, I forgot. Here, the most you can see in this example actually is the failure index. One way of viewing the strength ratios here, just because this example is relatively convenient. Let me go ahead and scroll up through this. You can view the strength ratios in the F06 file. So here, if we scroll up, and there are a number of elements in this example. There is a section devoted to strength ratio output. So that's where you see it here. Or that would be for, or rather, I'm referring to this section here. So here is element 148. And you can see that for the next element, you have the same strength ratio. So that's perfect. We can look at just one element. For this element, we see that we have strength ratios of 1.11, which is exactly at the design constraint. For ply 3, we have a strength ratio of 1.107, so that's close to the upper bound of the constraint. But overall, you can see that all 8 plies are within the maximum, or the minimum constraint actually, that I defined earlier. So that's how you define a constraint on the strength ratio for a composite laminate. As always, I'd like to thank you for watching this video and any other video I've created. If you have comments, feedback on how to improve these videos, if you want access to the more advanced training, if you want me to guide you, offer myself to mentor you, if you want access to the web app, you can email me at this email address. I'll definitely reply back to you as soon as I can. With that, thank you for watching.